Hello everyone, this is Professor Rathod from the Scholar Academy. So friends, today we are going to discuss very important topic from the organic chemistry, that is halogen derivative of alkane and arenes. Okay, so from this topic, today we are going to discuss very important reaction, that is SN2 reaction mechanism. So first of all we see what is meant by SN2 reaction. So S stand for substitution, N stand for nucleophilic and 2 stand for bimolecular reaction. That means in this reaction 2 reactant molecules are involved. Okay, so that is the SN2 reaction. So SN2 reaction involve 4 steps. So now we see first step. Step first is the hydrolysis of methyl bromide. Hydrolysis of methyl bromide. Okay, so now we see the structure of methyl bromide. You know the structure, CH3Br. This is the structure of methyl bromide. Okay, so methyl bromide reacts with NaOH. So it is in aqueous form. NaOH is in aqueous form. So here NaBr is removed like this. NaBr and OH group is the nucleophile will be attacked here, and here we get methyl alcohol. CH3OH is the methyl alcohol. Okay, are you clear how methyl alcohol will get? So methyl bromide reacts with aqueous NaOH. Aqueous is nothing but NaOH can dissolve in water. So that's why this is a hydrolysis. Hydrolysis, the process in which we can add the water molecules. Okay, so methyl bromide reacts with aqueous and NaOH. So from this methyl bromide, Br group is removed, and from NaOH, Na group is removed. So NaBr is removed, and the nucleophile going to be attached here, and here we get methyl alcohol, and byproduct is NaBr. So this is the first step. So second step is the kinetic study. Second step is nothing but the kinetic study. Okay, so in kinetic study, what you have to see? Kinetic study, you know the chemical kinetics. Actually chemical kinetics is the branch of chemistry which deals with study of rate of chemical reaction. So here we see what is the order of reaction. Okay, rate of reaction always depends upon the concentration of reactant species. You remember that concept, that is very important. Rate of any chemical reaction always depends upon the concentration of reactant product. Okay, so here whatever product we get, methyl alcohol, that depends on concentration of methyl bromide as well as NaOH. Okay, the concentration of methyl alcohol means whatever methyl alcohol here we get, that will depends upon concentration of methyl bromide as well as NaOH. So that's why it is a second order reaction. So in SN1 order to discuss, there will be the first order reaction. In SN2 this is the second order reaction. Here we can write rate is directly proportional to concentration of methyl bromide and concentration of OH minus from NaOH. Okay, then rate is equal to, this proportionality sign will be go, then K is the proportionality constant. Rate is equal to K, concentration of methyl bromide and concentration of OH minus. Okay, therefore this is the second order reaction. This is the second order reaction. So order of reaction always depends upon the concentration of reactant species. Here it is a second order because rate of this reaction depends upon concentration of methyl bromide as well as concentration of NaOH. So that's why this is the second order reaction. So now we see step third, that is the rate determining step, that is the RDS. Okay, so in second step just we have to see how rate determining steps will be changed accordingly patterns. Okay, just we see the second step, step third, that is a rate determining step, that is a mechanism. Rate determining step, this is a RDS, rate determining step. Okay, so just we have to see according to their stereochemistry how this reaction will be changed. Okay, this H, this H, and here we can write, this is a H above the plane and this is the below the plane, and here we can write the bromine group like this. Okay, this is a methyl bromide, this carbon and having the 3 hydrogen, H, H and this H, and this is the bromine group. If nucleophile will be attacked from backside attack, so already I have to discuss it SN1 reaction, stereochemistry. If backside will be attacked, then there will be the change in configuration, that is nothing but the inversion in configuration. Okay, so this is the RDS, that means rate determining step. Okay, if nucleophile will be attacked, then what happens? In any chemical reaction, you have to remember one thing. Okay, one bond is break and another bond will be formed. There will be the bond breaking and bond making takes place simultaneously. Okay, if OH group will be attacked here, then there will be the formation of new bond and this bromine will be removed, that is the bond is breaking. Okay, so that can be shown in TS, transition state. Okay, like this CS3, there this H group is remain as it is, and this OH we can show dotted line because that bond is going to be forms, and this leaving group, that means bromine, that also we can show dotted line because this is a bond will be start to breaking. Okay, and here this H we can represent it as it is, and this H we can represent it same like it, above the plane and below the plane. Okay, this is a transition state. TS, transition state, is nothing but the intermediate, that is in between reactant and product. Okay, finally what happens, this bromine group will be removed. Okay, here bond will be new bond will be formed and this old bond going to be break, that means bond breaking and bond making takes place simultaneously, and here we get the product like this, this C, this H, this OH group will be here. Okay, and this H, here we get the methyl alcohol. Okay, that means if backside attack takes place, then there will be a change in configuration, that is the inversion in configuration. If front side attack will be there, there will be the retention in configuration. Okay, so now we see last step, that is the energy profile diagram. That is very important. So according to this mechanism, this stereochemistry, we can draw the graph like this. Here we can show the graph. Step fourth, very simple graph this one. Okay, just we can show the graph like this. Okay, so this graph, reaction coordinate versus potential energy, okay, reaction coordinate versus potential energy. So just we have to see here, so here is the reactant. Okay, that means methyl bromide here. So reaction will be start only one step there, that means we get only one peak like this, and here we get the product like this. Here we get product. This is the delta H, change in enthalpy, and this highest peak we get here, that is a transition state, that is the delta E, activation energy. Okay, so here in energy profile diagram, what we have to see, this is the energy profile diagram, this is a step 4th. Okay, energy profile diagram is nothing but the graph of reaction coordinate versus potential energy is called energy profile diagram. So in mechanism what we have to see, here reaction will be start, and here we get the transition state, and here we get the product. Okay, so from reactant to transition state, the highest distance is nothing but the activation energy. Okay, and product to reactant, the distance is nothing but the change in enthalpy, that is the delta H. Okay, in some chemical reaction, delta H is negative, that is the exothermic reaction, and in some chemical reaction, delta H is positive, that will be the endothermic reaction. Okay, so this is the energy profile diagram. Okay, so in next lesson, in next session, we are going to discuss the very important chemical reaction regarding the halogen derivative of reaction. Okay, thank you so much.